Hello and welcome to Lesson 3 in Unit 6, Solving Problems with Quadratics in our Grade 10 Academic Math class. Today's lesson is Optimization Problems Part 2. So if you've watched the first Optimization Problems video, you'll remember that one of the things that we look for to identify optimization problems is a clue word in the question that indicates some optimal value, whether it says maximum or minimum, biggest, smallest, most, least, any of those things that indicate we're looking for a value that is at the extreme. And this first question that we're going to look at, our first example, is a fairly common question you'll see when we're doing quadratics in grade 10 and in grade 11. And these are what we call revenue problems. So let's just jump right in. A retailer finds that 100 sound systems per month can be sold at a price of $500. For every $10 decrease in price, he sells 5 more sound systems per month. What selling price produces the maximum revenue, and how many sound systems will be sold at that price? Okay, so we have our clue word right there. As we're reading this and we're being attentive, we see the word maximum. So maximum is going to indicate that we are looking for a vertex, and as you can see, I've written that down in there. I've also, for this question, already outlined our let statements, and I've also included sort of the first equation that we're going to be sort of building off of when we're dealing with revenue problems. So if you need to pause and then sort of fill this stuff in, that's a good time to do it. And then when you come back, I'm going to keep sort of talking about how we develop revenue questions. Okay, you've copied it down. So the thing about a revenue question is revenue, if we're just talking about what revenue is the product of the price of something, so how much it costs. This is sort of the way that I talk about it in class, as I say, this is the money one, and this is the number one. So it's however many you sold multiplied by whatever the price is to sell one of them. That gives you your revenue. So revenue questions are going to be quadratic because we're multiplying two things together in the same way that an area question is or could be an optimization problem because it deals with an area, and an area is a second degree equation. Like this, revenue equation will be a second degree equation. So how do we go about building it? Well, if we're going to build this equation, first thing we want to do is define our variables. We let R represent the total revenue in dollars, and let N represent, now this is important, let's let N represent the number of price decreases. Now where did I get that from? Well, I got that from the question. So the question, after the first sentence, it says, for every $10 decrease in price, he sells 5 more sound systems per month. So what we're doing is we're setting up a relationship here between the price and the number of units sold. So we know there are going to be some $10 decreases. We don't know how many. That's what we're going to try to figure out to help us get this maximum revenue solved. So a $10 decrease, how do we articulate that in here? Well, let's just change up our colors. So R for our revenue, and then let's set up the price, and let's set up the units. So what we know is that the original price of the sound system was going to be $500. And the original number of sound systems sold was 100. So when the price was $500, they sold 100 per month. We're going to make a change to this. As you know, we are going to introduce a $10 decrease. So the $10 deals with price. So I'm going to do a $10 decrease by subtracting 10. And every time I subtract $10 off the price, the number of units I sell is going to go up by 5. Again, this is right out of the question. What we don't know at this point is how many $10 decreases will lead us to our maximum. And then by extension, how many 5 more sound systems sold will lead us to our maximum value. So this is where we are going to be putting our variable. A certain number of $10 decreases corresponding to a certain number of 5 more units sold increases. That's what's going to lead us to our maximum. So these are the adjustments that we've made. Hopefully this makes sense to you, the way that we developed this revenue equation. Because from here, we're just going to be expanding it out and getting it into standard form again, as we do with these optimization problems. And then we go from standard form to vertex form by completing the square. So let's expand this out. We're going to do 5. So we're just going to be foiling this thing, just sort of expanding it out. And then we're going to gather our like terms. I'm not going to draw all those arrows in. You know what I'm doing now. So we've got 500 times 100 is going to give us our 50,000. Then we have plus 2,500 N minus 1,000 N and then minus 50 n squared. Okay, so there's our expanded out version. Now we're going to gather together our like terms and just sort of reorder these so that they're in the descending order of degree. So we're going to have our squared term first, our quadratic term first, and then we're going to have our linear term next. So that's plus 1500 n, and then plus 50,000. Okie doke. So here we have our equation. In standard form, we're going to be completing the square. So in order to complete the square, we're going to start by common factoring out negative 50 from the first two terms. We're going to common factor out the a value. So I'm just going to do that over here. I think I'm going to just complete the square since I don't want to run out of room as I'm doing it. So we're going to complete the square. And that was r equals negative 50 n squared plus 1500 n plus 50,000. Okay, so that was just a rewrite, and now we are going to start completing the square. So let's common factor out negative 50, and that's going to leave us with n squared. Now I've factored out a negative value, so this is now going to be a negative here, minus 30 n. Now I'm going to add something, I'm going to subtract something, and then there's my plus 50,000 kind of hanging around there on the outside. Okay, so now we are going to figure out what values will allow us to create a perfect square trinomial. The way that we do this, of course, is to take our b value and cut it in half, so that'll be negative 15. To square that is 225, I believe, and then we are going to subtract it as well. So what we've done here, we've set ourselves up a perfect square trinomial. That's what this one did. This minusing 225 is just keeping our equation balanced. So let's get that negative 225 out of this bracket so that we can factor it. We do that by multiplying it by a. So we're going to multiply this by negative 50. Let's see what our next line is going to look like here. So we have r equal to negative 50 bracket n squared minus 30n plus 225. And now outside my bracket, so negative 225 times negative 50, that's going to give us 11,250. And there is our 50,000 already hanging around outside there. All right, so now we simplify and we factor. So let's go about it. R then is going to equal negative 50. Now I'm going to factor this. It's going to be an n. We have a negative b value here, so we'll have a negative in here. And what multiplies to 225 and adds to negative 30 is going to be negative 15. And we are going to combine these two together here. So we have 11,250 plus 50,000. That's going to give us 61,250. So this is our vertex. Our vertex right here is telling us 15 and $61,250. Okay, so let's just look at the interpretation of what our vertex is here. So again, our vertex, these n's would be our input values, and this capital R, our revenue, would be our output value. So again, what we were looking for in this question is what value of n will result in a maximum revenue. So in this case, this is the number of $10 decreases, I think it was. Yeah, so that's the number of $10 decreases, and this $61,250, that's our maximum revenue. So let's just cycle back around to the question. Since the question asks what selling price produces the maximum revenue and how many sound systems will be sold at that price. Now, it didn't leave us a lot of room to do this, so I'm just going to sort of squeeze it in somewhere. But remember, what we've done is we've articulated price over here. This is price. It's 500 minus $10 a certain number of times. We now know it's 15. And the number of units sold is going to be 100 units plus 5 additional units sold 15 times. So we're going to take each of those little subparts of this question, and now we're going to figure out what the maximum price, or sorry, what the selling price was for maximum revenue, as well as the number of units sold. So we're going to take that, and I'm going to squish it in here somewhere. Goodness, I really did not leave a lot of room. Okay, let's do price over here. So here's price. So we know that the price was going to be equal to $500 minus $10 15 times. And now we're just going to figure that out. Maybe I'll make those equal signs. Okay, so we have $500. We are going to subtract $10 15 times, and that's going to leave us with a price of $350 per unit. And now let's figure out the number sold. So the number sold will be equal to, it was 100 originally, and we are going to add 5 additional sales to that 15 times. So we put that into our calculator, 100 plus 5 times 15, that gives us 175 units sold. So now we need a little therefore statement to sum it up. I'm going to squeeze that in. Maybe I'll just squeeze it in over here. I apologize. I did not plan this very well. It's turning into a bit of a mess. So we would say, therefore, selling 175 units at $350 gives maximum revenue. Just shortcutting all over the place here. Not even a full maximum there, just a max. All right, so selling 150 units at $350 gives us max revenue. Whew, squeezed it all in there. Okay, so before we leave this question and look at that visual masterpiece I put together, let's just recap what we did. So revenue questions are common when we're working with quadratics. This one we're being asked to find a maximum revenue. That's our clue from the question. So we know we're going to create a standard form version that we're going to ultimately complete the square to find how many. In this particular case, we're looking for the price and how many units will be sold in order to get maximum revenue. So to do that, we need to create a revenue question, which is price times number of units sold. In this case, what we're doing is we're setting up adjustments. Questions like this set up an adjustment where for every $10 decrease in price, so from the 500 original dollars, we subtracted $10 an unknown number of times. That was our variable n. That'll be multiplied by the number of sound systems sold, that's 100, increasing by 5 an unknown number of times. So we see that n variable show up twice, such that when we expand it out, we end up with a squared value, a quadratic, as we knew we would. Then we just went on, we completed the square, found our vertex, interpreted the x component as the number of price decreases or sound system increases, depending on how you set it up. Going to be 15, so we find the price, we find the number of units sold by subbing that right back into the original revenue question portions that we had set up, and then putting a therefore statement on it. This is a very challenging question. You're going to see it a lot, so rewatch this video if you need to. Then come on back for part 2, and I think we'll be able to finish up this lesson in 2 parts. Let's see.